Well, Algebra Geometry 3 classes, once again, good morning, good afternoon, or good evening, whenever you may be watching these now. I know can be different. We're going to now look at the final half of section 6.3. It actually will not be any new material. Basically, what's going to happen in this is we're going to kind of sum up what we've done in the last two sets of notes. So if you have 6.2 and 6.3 day one, you could even have those handy just to look over. So when we have absolute value inequalities, the main thing that you have to watch for when we graph and set up our intervals is whether it is a less than or a greater than inequality. When it is a less than inequality, we are going to set up our two inequalities. One is a less than, and 2x minus 1 is greater than or equal to negative 9. I'm going to actually drop down to the next one before I solve anything just to show you the key difference. When you have a greater than, 5x plus 2 is greater than 8, or 5x plus 2 is less than negative 8. The reason why you have and or, you can have things that are less than 9 and greater than negative 9. You cannot have anything that is greater than 8 and less than negative 8. So that's the reason for the difference there. Now all we're going to do is come in and solve each of these. So add 1, so 2x is less than or equal to 10. Divide by 2, x is less than or equal to 5. And add 1, 2x is greater than or equal to negative 8. Divide by 2, and x is greater than or equal to negative 4. Again, just like the others, we will set up our number line. Negative 4 is smaller, goes on the left. 5 is the larger value, goes on the right. They are equal to, so I will use closed dots. Now, here is the key. Less than or equal to 5 means I'm going to have it point left. Greater than or equal to 4, when it's greater than, it points to the right. When they are pointing inward like this, we do go ahead and connect. And our interval starts at negative 4, stops at 5. Closed dots, we will use brackets. All right, now down to example 2 to really show you the key difference. Here, subtract the 2. 5x is greater than 6. Divide by 5. X is greater than, if you want, 1.2 as a decimal, or leave it as a fraction. Here, subtract 2. And you get negative 10. Divide by 5. X is less than negative 2. And from here, when we set up our number line, negative 2 is smaller, so it goes on the left. 1.2 is larger, goes on the right. Now, when we have values that are not equal to, I am going to use open dots. Greater than 1.2 is going to point right. Less than negative 2 will point left. I know one of the things that I've often heard is kind of the way to remember this. When it is an or, think about, if you're on a boat. The oars on a boat point outward. So that's kind of what we have going on here. As far as our intervals for this one, again, this is pointing to the left, which means it's going to negative infinity. Stops at negative 2. Open dot means parenthesis. When we have a split interval, now we're going to use that union symbol. Again, open dot, so parentheses around the 1.2, and it's pointing to positive infinity. Now, examples 3 and 4. Biggest issue here is when you have this number, either the plus 6 or the minus 2, you want to move that first. So 2x minus 5 is greater than or equal to 5. I'm just going to come down here and do the same thing on this one. 2x minus 3 is less than 12. Now I can set up my two problems. So for this one, 2x minus 5 is greater than or equal to 5 because it is a greater than, or 2x minus 5 is less than or equal to negative 5. Coming down to this one, 2x minus 3 less than 12, when it's a less than, and 2x minus 3 is greater than negative 12. Remember, when you set up your negatives, you flip the inequality, change the sign. And now I just solve things out. Add the 5, so 2x is greater than or equal to 10. Divide, and x is greater than or equal to 5. Or add the 5, 2x is less than or equal to 0. Divide, or x is less than or equal to 0. Before I worry about solving the bottom one, I'm going to just quickly set up my number line. 0 is smaller, goes on the left. 5 is larger, goes on the right. These are equal to, so I will use closed dots. Greater than or equal to 5, points right. Less than or equal to 0, points left. Again, pointing left means it goes to negative infinity, stops at 0, closed dot, gets a bracket. Again, the 5 points right. I realized I was drawing something that you couldn't see on the screen because the 5 is greater than. Again, a broken interval, union. 5 has a bracket for a closed dot, and it's pointing to positive infinity. All right, final one, as this set of notes is definitely shorter since we're not really going over anything new. So 2x is less than 15. Divide, and I'm running out of room here. So 15 divided by 2 less than 7.5. Add the 3. 2x is greater than negative 9. Divide the 2. X is greater than negative 4.5. Now, something a little different does end up, happening here with this one, when, again, from the one we just did, because you now have your and. Negative 4.5, positive 7.5. They are not equal to, so I will use open dots. The greater than negative 4.5 points right, less than 7.5 points left, and we will connect those. And then our interval, negative 4.5 stops at 7.5. If you notice, when the dots connect, you just have a single interval. When the arrows are pointing opposite, you do have the two separate intervals. So again, 6.3 has a couple of assignments on Schoology. Really wasn't anything new here with this group of notes. It was just kind of, to outline the differences as to when you have a greater than, meaning an or, and the less than, which is an and.